Good evening, my 11th standard warriors. It is said that a couple of 100 years back, when there was plague throughout the world, Newton, during his home quarantine, has invented his laws. So that's what he did during those lockdowns, and he thought about the Newton's law of gravity and all the laws that we hear about, talk about, and use it for solving problems. Well, you might not like it, but let me also tell you, the Industrial Revolution and the explanation of many phenomena happened only because of the Newton's laws. We know how things work, how things move. The dynamics of motion is clearly explained by Newton's laws, and he laid the foundation of the Industrial Revolution that happened in the 20th century. So let's see what these laws are, and what's free body diagrams, and what are the basic forces which we need to account for, and how to solve problems of Newton's laws. All this with me, your physics master teacher at Vedantu, going live. I'm also the HOD for JEE Physics Division. I have been teaching for a very long time, and many of my students have cracked the JEE examination, and many of them are in IITs, BITS, NITs, and any other top prestigious institute that you can ever think of. And most of them, in fact, have graduated from them. Some of them are studying in IITs and NITs, and I really hope next year and next to next year, many of you are going to be there. Especially the 11th standard students, 2023. Mark the calendar, guys. That's the year you are going to make it to IIT. I am pretty sure with all your hard work, with all your patience, with all your trust in me, I'm going to make sure that happens. So welcome aboard. And if you want to know more about me, you know where to follow me and stalk me. You can stalk me out here. Hi Zayed, hi Charita, hi Rajni, hello Tushar, hello Jitesh, hi Ankit, hi Ratish, hello Saja, hello Jai. Hello Ankit, hello Srija, hello Gifta, hi Nikhil, hello 𝐊𝐕𝐏𝐘𝐞. Good evening, good evening, good evening everyone. Hi Abhishek, hi Suchi Mama, hello Esther, Rohan, Manvita, Darshan, Akash, Jaivan, Sheshari, Katuri. I'm hoping that I've taken all the names, but if I missed somebody's name, sorry guys, but a lot of names coming up. Thank you for being here, and don't worry, I'll keep taking your names as and when you answer the questions. So yes, I'll take your names, don't worry, just make sure that you are attentive and answer all the questions that I give you very soon. And before we start the lecture, you know what to do. A simple favor for me, to show your love, shower your love, smash the like button, and if you are new to the channel, go smash the subscribe button, because it's for free, number one. Number two, that's the fees for attending this class for free, you can say, like a Guru Dakshina. And you will also get regular updates. You'll also not miss any classes only when you subscribe and hit the like button, because or else the way YouTube works is that it pushes up those videos which you like and which you subscribe to. Okay, now what's the schedule for this week? The schedule for this week, I think I have been showing it again and again, but still it's my job, I'll show it to you. Today we are starting with Newton's laws, lecture 1. Second lecture, pulley block problems, tension problems, inclined plane problems. A lot of people face problems in that. So we're going to do those kind of questions on Friday. Special session Saturday. Thursday, that's for 12th standard, that's motional EMF and Hall effect, that's tomorrow. And in case you have missed the first class of electromagnetic induction that was conducted yesterday, you can check it out in the playlist, it's already there. Alright, now let's see the first question coming up on your screen. Zayed, you will get to know very soon. Sheshagiri, if I was not the HOD of physics, I won't put it, right? Okay, so yeah, whatever we put out here, that's the truth. It's not like I have to just show off or anything. Alright, so let's see how many of you can get this. Hello Kalyani, welcome aboard. Hello Shiva. Hello Bugata. Come on, bacha log, join in. Jitesh saying C. Tushar saying C. Interesting. Rohan also saying C. Okay, Bhargavi, good evening. Ankit also saying C. Pranit saying C. They are all saying stays at rest. Forces F1 and F2. Ooh, interesting. Which of the... Oh, by the way, I forgot to mention this. but F1 equals to F2. I think it is missing in that question, but I'll add it later on. F1 is equal to F2 magnitude wise. So which direction do you think is the box moving? F1 is equal to F2. Come on, quickly. Some of you are saying, most of you are saying C. Okay, most of you are saying C. Interesting. Very few people are saying something else. Interesting. Well, guess what? Guess what? You guys are wrong. The answer is very good. Who is that? Salula Musa. Very good, Salula Musa. Can't say is the answer. Yep. Reason? How can you tell where is the box moving when the net force is 0? If the force acting on, a body cancels out with other forces, the total force is 0. So the object will continue to do whatever it was doing before. Now, what was it doing before is uncertain. I do not know that. It is not given explicitly in the question. So hence, I am not in a position to actually figure out what exactly is it doing. If it was moving towards the right, it will continue moving towards the right. If it was at rest, it will stay at rest. If it was moving towards your left, it will continue moving towards your left. So it will continue to do whatever it is doing, and hence the correct answer is basically can't say indeterminate. The forces were equal and opposite, so they cancel out. And I have a beautiful simulation to show all of this. Look at this. This dude on the skating board is moving unless and until he is acted upon by this external unbalanced force. Look at that. Look at that. F1 minus F2. Yes. No, Rohan, that's wrong. F1 minus F2 is equal to 0. Rather, F1 is equal to F2. So acceleration is 0. Net acceleration is 0. Velocity is constant. So that's where a lot of people made that mistake. Dharmarajan, see, this is what happens in school. You have to unlearn a lot of things. You have learned so many things which are wrong or which are incomplete or half truth. A lot of people think when forces cancel each other, the object is at rest. Wrong. Understand, when forces cancel each other, the object may be at rest. It's not necessary. Understand that. It's not necessary. So this guy, he's moving because there is no net force acting on him. He's moving on a smooth surface. Gravity is there, normal is there, but they are cancelling each other. Net force is 0, so he'll continuously move with constant speed. As soon as there is a force, his momentum will change, his velocity will change. I hope this is clear. So that is what actually Newton's first law is all about. Newton's first law is all about this. So how many of you remember what is Newton's first law? Yes. Venkat, there are different batches, right? So today is nurture batch for 11th. So you have to check the timetable, which class you are attending, plus you have to read the description box, which lecture, whose class is this. Okay, so that way you will get to know, what is the flow of the classes. All right, great. So if you remember that, you will remember this. When there are no unbalanced forces, the object continues its state of inertia, it continues its state of motion uniformly unless there is some unbalanced force which will change the direction or the speed of the motion. So that's the vague description of the first law. But before going to the first law, let me remind you guys, and let me in fact congratulate all the 10th standard students who have got amazing results. And guys, if you have got your results out, especially if you are from CBSE, post it in the chat box so that everybody knows that. And I'm really happy. And by the way, many of the 10th standard students have also cleared NTSE examination for the stage 2. And these are all Vedantu students. 100 plus students from 10th standard, guys. That's amazing results. Congratulations to all the NTSE qualified students, and congratulations to all of you who have cleared the examinations, and welcome to 11th standard. I hope now that official stamp is there on all of you for getting in the 11th standard. So don't worry about NTSE, Ditesh. If you do not know, it's a national talent search examination for 10th standard. So in case you have missed it, now you cannot do anything about it. Now you're in 11th. So for 11th, there is similar exam called as 𝐃𝐕𝐵. I have conducted a class on 𝐃𝐕𝐵. Just check it out. The batches have started. The batches have started on 2nd of August. There is one more batch starting for 𝐃𝐕𝐵 this Monday. So do not miss that. And when you are a part of Vedantu, we give you the promise that your ranks, your percentiles, your scores will improve from where you join. So we conduct tests before you join Vedantu, and we will see to it that you improve. And if you don't improve, all the money is returned back. And that's what is Vedantu Pro. The courses are in fact starting every now and then. But there was a batch which just started on 2nd August. There will be another batch, but it will start after more 2 weeks. So if you want to join Vedantu and you want the long-term batches with 𝐾VPY preparation and with doubt solving and the notes and the assignments, the courses are for as low as 2,700 rupees per month. Go check out the link in the description box. And when you use my coupon code SHHPRO, you get 10% flat off. Okay, so I'll talk about it in detail again at the end of the class, but yes, there is a link below. So coming to Newton's first law. Newton's first law is nothing but when an object is at rest or it is moving uniformly with constant speed, that is okay, or with constant direction, it will continue to remain at rest or it will continue to keep moving uniformly unless and until it is acted upon by an unbalanced force. So guys, look at this. Imagine if there is an object at rest, then the forces might be there, but they might be all cancelling out each other. So if they cancel out each other, you will see the total force will be 0. So if the total force will be 0, then it will be either at rest or it might move, but if it moves, it will continue to move with constant velocity. So understand, when net force is 0, velocity is not 0. Velocity is in fact constant. Keep this in mind. That's what was happening in the box question. The net force was 0. The velocity was constant. The problem was I didn't know what the velocity was. So that's how it is. Yes. So Sri Lakshmi, there is a link, bacha, in the description box. You can purchase the courses from there. Okay, you can check it out. It's there in the description box. Okay, great. Good evening, Dayani. Yes, that's the Newton's first law. Yes, correct. Cracked with Gokulnath. All right. Chalo, let's get going. Kanduri, Aruna had conducted a backlog class for entire syllabus of vectors, 1D and all that. You can watch that. Number 1. Number 2, there is my recorded class of vectors which is there in the playlist. Please watch that. Number 3, the batches are starting. You can watch vectors live when you join the batches in Vedantu. Now what is unbalanced force? Perfect question, Suchi Mama. Perfect question. Yes, I'm going to come to that. Sai Sanjay, join in bacha. Even you can go behind. Those of you are joining in little late, in a live class you can go behind, catch up at the current location at 2x speed. You can do that even right now. Now what is the meaning of balanced forces and unbalanced forces? See guys, the thing is, balanced force means all the forces cancel each other. Unbalanced means probably the forces have an unbalance. That means they do not cancel out each other. So imagine you are pulling a rope. You are pulling a rope. These people are pulling the rope this way. This person is pulling the rope this way. None of them are moving. So hence the forces are cancelling each other. That's a balanced situation. But when the forces do not cancel each other, then there is an unbalance. And what happens when there is an unbalanced force? When there is an unbalanced force, the velocity won't remain constant. Keep this in mind. When there is unbalanced force, then the velocity won't remain constant. What all things can change when there is an unbalanced force? Either the speed can change, or the direction can change, or both of them can change. So if I apply an unbalanced force, the speed might increase or decrease. The direction can change. I can deflect an object, or I can change the speed while I am deflecting it. So any of these things can change. I hope this is clear, and if this is clear, please put up a thumbs up in the chat box right now. Okay, so I hope this is clear. So unbalanced means net force is not 0. Balance means the vector addition of the forces, vector, understand, is 0. Okay, great. So Rohan, if you're not perfect in kinematics and projectile, very simple, watch my lectures, bacha. It's all there in the playlist. Okay, so all the students who are a little bit late in identifying this channel or who are very new to the channel, all my lectures, vectors, 1D kinematics, units and dimensions, basic maths, integration, derivatives, 2D motion, relative motion, all is there in the Nurture series playlist. Just check it out. Let's see how many of you can do this question. Very good. A lot of you have put up a thumbs up. Very good. Jai, Payal, Bhargavi. Excelente. Vangala, Sundari. Yes. Now, crack it, Gokulnath. In fact, that question is going to come up very soon. Just hold on for that. In fact, whatever you have told, it's a question. Okay. Which is R correct for balanced and unbalanced forces? More than one option may be correct. More than one option may be correct. Let's see. Oh, thank you so much, Payal. I'm so glad you are saying Newton and Shreyas sir. Both are your favorites. Thank you so much. Kevin, welcome aboard, bacha, and please hit the subscribe button so that next time you do not miss my live classes, and check our schedule which is there in the Telegram group. I'll post all my schedules in the Telegram group as well as in the community of YouTube. Okay. Darshan, even if you're a NEET student, you can still watch it, bacha. Okay, let's see how many of you can get this. Read the options carefully. More than one option. Advanced pattern kind of question. So in advance, you see more than one options being correct. Let's see how many of you can do this. Okay, Suchi Mama says ABC, Kevin says sure, all right, Sarvesh ABC, everybody saying ABC, 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 very good, excellent, guys. So a balanced force, all the forces cancel and the body remains in equilibrium. Equilibrium means, you know, you stay as it is. You do not change your state. That is the meaning of equilibrium. Like this one, you have same cars on both sides of a seesaw, or two people of same weight at same distance. That's balanced. That's equilibrium. Unbalanced means there is no equilibrium. You can see that. If you put more weight here, then it is toppled. It disturbs the equilibrium. So net force is not zero when the forces do not cancel out each other. Correcto. So hence the correct answer is, if the forces acting on a body results in some change, then they are unbalanced. Correct. Unbalanced means they will result in some change of state. The velocity will change. For an object in equilibrium, the net force is zero. Correct. The total force acting on the body will be zero. And for an object which is not in equilibrium, the net force will not be zero. And the last thing, an object in equilibrium will always stay in equilibrium. No, that is not always true. There is a condition for that. And the condition is only if net force is zero. Only if net force is zero. Now that is not mentioned. Hence, option D is incorrect. Very good. Excellent. So understand the meaning of equilibrium means, you know, stays as it is. Stays as it is. Like balancing this pen. This is in equilibrium. Okay. If I leave it like this, probably, yes, it is in equilibrium if I'm able to hold it like that. Correct. Or if I hold it like this, this is in equilibrium. But if I move this pen, yes, this is no longer in equilibrium. Very simple. Cool. Let's get going to the next question coming up on your screen. Now, this is a beautiful question. Who doesn't like to drive a car or a bike or a cycle on curvy roads? Everybody likes that. And we all have experienced this. Whenever a car or a bus goes on a curved road, you get pushed towards one side. Correct? And it's fun. And especially when you are turning at very high speeds. Do not do that at home or on the streets. Okay. So let's see what the question is. And the passengers in a car are thrown outwards when the car takes a sudden turn. The force acting on them is weight, inertial force, contact force, no force. Many of you are going to get this wrong. I'm pretty sure about this. I'm telling you now itself. Many of you are going to get this wrong. I knew this. I knew this. I so know you guys, man. I mean, like, it's like I know you guys inside out. I know you guys very well. All right, I think only Zayed YouTube got it correcto. Excelente. All of you got it wrong. Guys, the answer is no force. Yeah, only one option, no force. Like, sir, what the hell, sir? All my life was a lie. I thought it was inertia. Inertia is not a force. It's something else. Inertia is the tendency to maintain your motion. Tendency. Tendency is not a force. Understand, there is a difference. The question should be read properly. The force acting on those passengers. Force. Inertia is not a force. Understand the difference. A lot of people get this wrong and you will lose marks. You will get -1 marks in your mains or BitSat or whichever exam you're going to write. Be careful. So what is exactly happening is, when a car turns, every object has a tendency to move in whatever in whatever direction and whatever speed it was moving previously. So the passengers of this car have a tendency to move like this, right? So the passengers in this car have a tendency to move like this. Now it's the car's fault. It's not your fault. It's the car's fault. The car turned like this. So the passenger, what the hell? I want to move like this. That's my tendency. The car will be like, no, I'm going to turn that way. So fine. Relative to the car, you move outwards. You feel that you are pushed outwards. But imagine a Pandu, Bichara Pandu, standing on the ground and eating peanuts. He's eating peanuts, standing on the ground. What will the Pandu say? A Pandu will be like, okay, the passenger inside the car is just moving straight. That's his tendency. Oh, so big deal. What's so great about it? That's what everybody wants to do. He wants to just move in a straight line. The people inside the car feel, oh, somebody has pushed me outwards. But the fact is, nobody has pushed you outwards. It's the car's fault that it turned. Actually, you would have moved in a straight line anyways. Is that clear? Is that clear? Okay, Mukesh Bacha, I will do that. No, the contact force will not be responsible for throwing you out. In fact, the contact force is in fact acting in a very different direction. If you are sitting in the car, the contact force will be acting this way. The contact force will be acting this way, and there will be friction. The friction will in fact prevent you from being thrown out. Okay, the friction will prevent you from being thrown out. Imagine the seats were slippery. You just slide out, right? You just slide out. So the friction in fact prevents you from being thrown out. Okay, great, great. Inertia of direction, there is nothing like inertia of direction force. Understand, inertia is not even a force, first of all. Okay, what is contact force, Bharti? I'm coming to that. In the next few classes, you will get to know more about contact force. Okay, Giri Bacha, this is JEE channel. So even if you are a NEET student, you can still attend my classes because physics is physics. Newton's first law will remain like this. Understand? It's not going to happen, sir, in JEE you are thrown outwards, but in NEET you will be thrown inwards. So you need separate lecture series for NEET and JEE. It's going to be the same. So even if you are a NEET student, you can attend it. Okay? Chalo, let's get going to the next question. Okay. Now this simulation, Sarvesh, it will come in circular motion. You have to wait for it long time. Newton's laws, then circular motion will come. This is a beautiful demonstration of inertia. So if you have some coin or some heavy object placed on a sheet of cardboard or paper and you pull it instantly, because of inertia, the tendency, see what was the ball doing? The ball was at rest. It wants to be at rest. It's like, no, I don't want to move. That's my condition. That's my tendency. So when you slide it quickly, so because of its tendency, once you move the paper, it will be like, oh, where is the ground? It's gone. So I need to fall. So that's why it will fall back, fall inside. Yes. So that's how it is. Okay. So now, guys, Shaktivel, everyone, I have already talked about what about pulley problems, etc. Please watch the lecture from the start. Don't keep disturbing the class in between. I have already mentioned at the start the timetable. So it's your duty to check out the schedule which is posted in the Telegram group, which is posted in the community, which is being told at the start of the class. Go check it out. Okay. Now, talking about inertia. See, a lot of people think inertia is a force. No, inertia is not a force, number one. Number two, inertia is actually the tendency of a body to maintain its position. And who has more inertia? The one which has more mass, the one which has more matter, the one which has more quantity, that has more inertia. And it's very easy to see that using this simple animation. This guy is trying to push both these people, you know, with the same force, but the one who is thin will swing a lot because they have less inertia, less tendency to resist the change. This fat person out here, his quantity, his matter, his mass is more, so he has more resistance to change his state of motion. His state of motion right now is rest, so he will resist it more. So mass indirectly measures inertia. I hope this is very clear. Yeah, so inertia is the resistance of any physical object. Read this line carefully. Inertia is the resistance of any physical object or any body to change its velocity, to change its motion, to change its state. It will resist. This guy resists more, this guy resists less, because his mass is less, this guy's mass is more. So it's a tendency to resist the change, and it is, you know, the inertia of translation motion is measured in terms of mass. So kg is the unit of mass. Inertia is not proportional to force, bacha. Inertia is proportional to mass. More the mass, more the inertia. More the force, how can inertia change? Imagine, if I apply more force, will your inertia be more? No, right? Your mass will still be the same. You have the same inertia. When the force is more, your effect, your acceleration, your velocity will be more. Mass won't change. Get the difference. Okay, I hope this is clear. Okay. No specifics as specify the force is not there in the previous question. There is no force which is pushing it outwards. Understand that. It's just the tendency. It's just your way of looking at things. From the ground frame, if you see, it's a straight line motion, which anyways it should do. From the passenger's perspective, they just look as if they are going outwards, as if somebody is pushing them out. But it's just a perspective. It's a frame of reference thing. Yeah, cool. Yeah, I hope this is clear. Everybody fine till this point? How many of you had a lot of misconceptions till this point? These are simple things, but still I'm pretty sure, you know, Kunj, please don't say that force is not proportional to momentum. That is wrong statement. Guys, that's the problem. You guys have learnt many wrong things. ऐसा लग रहा है कि मतलब, you know, I have to not teach you, but first I have to make you guys unlearn things and then teach you. So that's a very much more difficult task. I mean, teaching somebody is easy. Making them unlearn something and then teaching is much more difficult. Trust me on that. Okay. Cool. Now, talking about internal and external forces. Vinkesh, sir, in frictionless surface, due to inertia, it should resist external force, sir. Very good question, Vinkesh. Just think about it, Vinkesh. If you have a frictionless surface, you throw a body, what will it do? It will continuously keep moving, right? It will never stop. Okay. What are the forces acting on it? You might say weight is there. But hold on, weight will be balanced by the contact normal force. So net force will be zero, right? Correct? On a frictionless surface, on a horizontal surface, if you throw the body, it will continuously move. Net force is zero. So if net force is zero, it will never stop. Understand this? Now, if you try to stop it, by some force, you will feel that resistance if the mass is more. Understand? That's what inertia is. Okay, I hope this is clear. Okay, great. Now let's get going to the next one. What is a system? What is internal and external force? Now this is very important slide. I mean, every slide is important in today's class. Here is the thing. What is a system? System is a part or collection of bodies in which you have interest or whom you are trying to analyze. For example, say, you know, you might have a block, you might have some pulley, and you might have somebody pulling it, okay, and maybe some person, maybe some Pandu is trying to pull this, okay. So if you are interested in the block's acceleration, what you will be doing, there are so many things. There is a thread, there is a pulley, there is a Pandu, there is ground, there is block. You will isolate this block. So this block becomes my system, and you will try to draw the forces on the block. You will try to figure out the acceleration of the block by isolating it separately. So that is what a system is. How do you decide a system? There is no rule. But how do you understand what to choose as a system? You will get a hang of it as and when you solve more problems. Initially, this might seem very trivial because you might not get affected by it so much. You might not think, oh, why choosing a system is so important. But as and when we move to more and more complex problems, you will understand choosing a system becomes very, very crucial, where you have multiple things over each other, maybe a block over block, and maybe there is another string, and maybe there is another block over here, and maybe this is moving, then what will you choose as a system becomes very, very important. So choosing a system is your wish. You can choose whatever you want. Answer will remain the same. Okay, so you don't have to worry about the final answer, but things will be more convenient if you choose the correct system or a more feasible or more practical system. Okay, I hope that's clear. Now, just like you choose the observer in kinematics, correct? Correct, yes. We're going to talk about different kinds of forces as well. Don't worry. Now, first is you can classify forces as internal and external. Now, what is the meaning of external force and what is the meaning of internal force? Simply put, just imagine this. There is a scooter, okay, okay, and there is a Pandu standing on it, okay, and he's pushing the scooter standing on the scooter, okay, he's pushing the scooter, you're standing on a scooter and pushing the scooter. Will the scooter move? Come on guys, let me know. So Salona, Musa, like I said, you will get to know which system to choose as and when you solve more and more problems. Savitri, Anita, everybody saying no. Correct, it will not move. Correct Bharti, correct Sham, correct David, correct Gifta, correct Crackpit Gokulnand. It will not move. Now, think about it. The force, or rather, first let's choose the system. If I choose this as my system, if I choose the Pandu plus the scooter as a system, think what is happening, guys. The Pandu is applying force on the scooter is applying force on Pandu. Pandu is pushing the scooter back, scooter is pushing the Pandu back. All those push-pull forces, Pandu pushing the scooter, okay, these are all internal forces. These are all internal forces because for my system, these forces are acting from one body to another body. Pandu on the scooter, scooter on Pandu. All these are part of the system. Pandu, scooter, all are part of the system. So whatever forces of interaction which are there, they will be internal forces. But hold on, imagine the weight, the gravity. Who is applying gravity, gravitational force? The gravitational force. Who is applying? Think about it. Earth on the Pandu. Earth on the Pandu and scooter. Now think about it. Is Earth a part of our system? No, right? I only took Pandu and the scooter as my system. So Earth is not a part of my system. Hence, this will be external force. Understood? Understood? Yes. So understand, depending on what you choose as a system, things can become internal or external. Now, here is the thing, guys. Here is the thing. If I choose Pandu plus scooter plus Earth as my system, then will the gravitational force be internal or external? Come on, quickly let me know. Come on guys, concentrate on the class. Come on, let me know. If I choose Pandu plus scooter plus the Earth as a system, then will the gravitational force become external or internal? Come on guys, think about it. If I choose Pandu, if I choose that Pandu, okay, plus that scooter which is there, plus the Earth, everything as my system, then the gravitational force, what will it become, guys? That will become internal force, because Earth is also a part of my system. Yes, correct. So do you understand whether a force is internal or external depends on the choice of my system. Depends on the choice of my system. And more often than not, is the external forces that matter. So you should not worry so much about internal forces. Right now in your body there are so many forces. Your heart is beating, correct? There is blood which is circulating, lungs are expanding, contracting. All those are internal forces. But because of the internal forces, will you start moving? Heart started pumping, suddenly you started moving. The lungs are expanding and contracting. you start flying up and flying down. Obviously that doesn't happen, right? So guys, understand, internal forces should not bother you so much. It's the external forces that you should be worried about a lot. Hence, whenever you draw or analyze a system, make sure that you do not miss any external force, because these forces are the ones which will produce acceleration. So they will accelerate. So I am a body, somebody pushes me. My center of mass, now what is center of mass? I'll talk about it later on, but everybody knows it's the point where the mass is concentrated. So if somebody pushes me, I'm going to accelerate. I can assume myself as a point object. But just on my own, I cannot say, oh, let me push myself and let me move. Okay, why am I not moving? Let me push myself. I will not move. This is internal force. I cannot push myself. I need somebody to push me. I need some support. That's why external forces are important. I hope this is clear, guys. Let's get going to the next one coming up on your screen now. Okay. Now, let's see whether we can analyze this situation. Let's see if you can analyze this situation. Which is external, which is internal. Let's just call these ladies champas. These are all champas. And we have a Pandu. He looks very retarded, guys. What do you think? He looks very retarded. I don't know why these girls are pushing him. Anyways, so here's a Pandu. He's just sitting here. They are enjoying. God knows why. Okay. Now, let's see what is external, what is internal. First thing, you should ask me, sir, what is your system? What is your system? Guys have already started putting up, sir, this is external, this is internal. Guys, understand, be careful. It depends on what is your system. Let's say my system is champas plus pandus plus the trolley. Champas plus pandu, okay, plus the trolley. Now tell me, what and all are the internal forces, what and all are the external forces? I think F1 will be internal. F1 will be internal. Okay, so let's just mark it. Internal forces. F1 will be internal. Okay, F2 will also be internal. I hope you can see that. F2 will also be internal. And what else is there? Weight and normal. Oh, I think these will be external, guys. In external, you will have the weight, normal and friction. Why? Weight is being applied by earth. Normal is being applied by the ground. Ground is not a part of the system. And friction, the friction which will resist the motion, that is also external, because that is being exerted by the ground, and ground is not a part of my system. I hope this is clear. Santwana Dangi, welcome aboard, join in Bacha. I hope this is clear. Yes. Is that understood? Niraj, we are going to come to attention force in a bit. Correct. Okay. Now, what if I change it a little bit? What if I only took Pandu plus trolley? Pandu plus the trolley as my system. Now tell me, guys, what and all forces will become internal and what and all forces will become external? I think there will be many external forces. Okay, so lot of forces. F2 is external, F1 is external, F1, F2, weight, normal, friction, all these are external forces. All these will become external forces, correct. Now, you might be like, sir, then what is the internal force? See guys, Pandu will be sitting on the trolley, right? So there will be some force on Pandu by the trolley. So that will be the internal force. Force on Pandu by the trolley, and vice versa. Okay, so both the forces, with the force which Pandu exerts on the trolley and the force which trolley exerts on the Pandu, those will become internal forces. Yes, is that clear? F2 is not internal, Rohan. See, who is F2? F2 is the force acting on Pandu by this second champa. So champa is not a part of the system, so that's an external force. Understand that. I hope this is clear. Check this out. So champa is applying the force. Kalyani, watch this. Champa is applying the force on the system. External. This second champa applying the force on the system. External. Weight by the earth. External. Normal by the ground, external. Friction by the ground, external. All these are external. Internal, internal. Okay, so that's why Jitesh, I'm telling you, right? F2 is the force by Champa, F1 is the force by second Champa on the trolley. So I hope this is clear. Similarly, understand this one more thing. This, yeah, some of you probably got confused that F2 is the force by the Pandu. No, look at this, the force is originating from here. So Champa is applying the force on Pandu. F2 is the force by Champa on the Pandu. She is putting it on his back. I hope now it is clear. Yes. Now Pandu is also sitting on the trolley. Think about it. That Pandu, okay, he will be sitting like this, right? So when he's seated, there will be some force acting on the Pandu. That is the internal force. Why? Because trolley and Pandu both are a part of the same system. When bodies within the system apply forces on each other, that becomes internal. Okay, I hope now it is clear. Hello Doraemon, you will not find it difficult once you study from the basics. If you study it haphazardly from some random book and you start with some very complex problems, obviously you will find it difficult. Okay, great. Now I hope this is clear. Now somebody, Monica B is asking, in before case also, is the force on Pandu by the trolley internal? Yes, Monica. In the previous case also, when I took Pandu, trolley, Champas as a system, even then this force which I have shown will still be there. But I know it was not shown in the diagram, but yes, that will still remain as an internal force. Okay, chalo. Let's get going to the next one. If everybody is clear about this. Okay, now somebody was asking, sir, when we run, what is the internal force and what is the external force? Let's see. See guys, if imagine you are running, okay, this is you. Now, who is our system? Let's choose this. Who is my system? My system is Pandu. Okay, my system is Pandu. Okay, think about it. What are the different forces acting on the Pandu? One will be the weight of the Pandu. Second force will be, the forces from the ground. Okay, let's say I call this F1 and F2. Also, when he's running, he's pushing the ground behind. He's pushing the ground behind, so the ground will push him forward. There will be friction, right? So there has to be friction over here. So that is F, let's say. So that is friction. Now tell me guys, which of them are internal, which of them are external? Which of them are internal, which of them are external? Think about it, very easy. Is weight external? Obviously it is external. Why? Because weight is the force on Pandu by earth. Earth is not a part of my system, so weight. Then F1, F2 by the ground. Ground is not a part of my system, so F1 and F2 as well. Friction. Who is applying friction? Friction is applied by the ground. Is ground a part of your system? No. Yes, it is applying on your Pandu, which is a system, but it is not. Ground is not a part of your system. Both the things should be a part of the system. Understand? The one who is applying and the one who is experiencing. Both of them should be inside the system. So hence, even friction is out of the, it's an external force. Internal forces will be like heartbeat force. Okay, your lungs expanding, your muscular forces. All those are your internal forces. I hope this is clear. Yes, Kshitij, I did. Yeah, pulling out hair, yeah, whatever he is doing. Now is it clear? I hope Rohan, now this is fine. So understand Rohan, internal means whenever you choose a system, both those things, the one who is applying and the one who experiences, both should be a part within the system. Now Pandu is only Pandu, he is not earth. So earth is external. Yes, if air resistance was there, then air resistance will be external force. Is that understood, Rohan? Everybody clear? Everybody clear about this? Please give me a thumbs up because this is very important. I'm pretty sure many of you don't know about this, and many of you or many of the coaching institutes directly jump directly into Newton's laws, pulley block problems, constraint motion, when you don't even know what the hell is this internal, external. If you do not know this, how will you understand it, guys? Thank you, guys. It means a lot. That small thumbs up, trust me, makes my day. You know, that's why I come here, so that you guys understand it. Okay, cool. Now, let's go to Newton's second law. Oh, by the way, till now we were just discussing Newton's first law. Okay, keep that in mind. Let's go to the second law. So I'm pretty sure you wouldn't have spent so much time on first law. I know what they do in coaching. Anyways, so second law, going to second law. For that, we need to quickly recap momentum. You would have studied this in 9th standard. Is the effect of mass and velocity. So more mass, more speed, more momentum. And the way you write momentum, it's m into v. It's a vector. So notice, I have put m in simple font, velocity and momentum in bold font. So whenever you see bold alphabets, treat them like vectors out here. So it's a vector quantity. So momentum is mass into velocity. So you can see the direction of momentum is the same as the direction of velocity. Cool? Shall we go ahead? Oh, Kshitij, were you? Oh, is it? I'm so glad to see you, man. Nice, nice. I'm not sure which center you are in. But yes, I used to teach in Pune long time back. And glad to see some of my students back here on YouTube. Interesting. Okay, so thank you, Anisla. All right, let's proceed. Newton's second law. Now, a lot of people think Newton's second law is F is ma. F is not ma. Wrong. How many of you thought that? If you thought that, you are wrong. Okay. What is Newton's second law? Newton's second law is basically the net force is the rate of change of momentum. It's directly proportional to the rate of change of momentum. That's Newton's second law. Newton never said F is equal to ma. He just said F is proportional to dp by dt. See, the first law told us, only told us when all the forces cancel each other, the body will continue to do whatever it was doing before. But what if the forces do not cancel each other? Well, there will be some unbalance. That unbalance will change the momentum. And how quickly you change the momentum is dependent on how much unbalance is there. More the unbalance, if the forces don't cancel each other, more the unbalance, more quickly the momentum is going to change. Now, using some simple rules of mathematics and physics, you can easily get one simple relationship. Momentum, like I just told you, is mass into velocity, correct? Okay, now mass is constant, so shift it outside. Oh, by the way, this should be proportional, all right? So hence, it is proportional to m into dv bar by dt. The only reason I can do that is because mass is constant. Now, it's not necessary mass is constant every time, because sometimes maybe a part fell off or something might get added. So in those cases, you cannot shift m outside, remember that. But we don't have those kind of systems in JEE. It's deleted, it's omitted from the syllabus. Okay, so net force will be proportional to m into dv by dt. What is dv by dt? It's acceleration. Now I can replace that proportionality with a constant, let's say k, and m into a, and now I can define a unit, and I can say if m is 1 kg and acceleration is 2 meters per second square, then the force acting on it is 2 Kshitij. It is 2 Kshitij. Okay, it is 2 Kshitij. Okay, so, oh sorry, not 2 Kshitij, my bad, 1 Kshitij. 1 Kshitij. Okay, so that's a weird unit, but it is a unit. In that scenario, I will write down 1 Kshitij is equal to k into m into a. Therefore, k is equal to half. Hence, my net force will be equal to half ma. Do you see that? Net force will be equal to half ma. I'm coming to that. Interesting. So that's weird. So understand, in the world we live in, we follow SI units. So for SI units, we need to have some standards. Everybody will choose, or else, sir, I want my unit, sir, then F will be 5 mA, it will be 7 mA, it will be 1 by 100 mA. Who knows? I don't want that. So to maintain uniformity, we said in SI units, 1 Newton force is when mass is 1 kg and acceleration is 1 meter per second square. And this is 1 kg. And therefore, if everything is 1, 1, 1, K will be 1. And therefore, net force is equal to MA. So, this is true under two conditions. What are those two conditions? Number 1, mass is constant. Who is constant? Mass is constant. What is number 2? In SI units or CGS units. Apart from that, if you follow some other unit, F maybe 5 mA, 1 by 7 mA, who knows? Is that clear? I just told you, bacha, William, K is the constant which depends on the units. Is that clear? How many of you got it? Oh, good to know, Kshitij. And please do recommend our channel to all your juniors, and would love to catch up with you someday. Nice to see my Pune students whom I taught in offline long time back. Really good, really good. Great, great. Chalo, let's get going to some questions coming up on your screen. So net force is MA under two situations. Number 1, repeat it. When mass is constant. Number 2, SI or CGS units only, not otherwise. Okay, let's see whether you can solve this question coming up on your screen now. Clearo says David. Schwibs also says thumbs up. Farhan also. Okay. Bukya, fine. All right, Roshni. Okay, Ria. Very good, Suganya. I hope you had a good time with the counseling. Very good, Kalyani. Very good, Suchi Mama. Very good, Nikhil Krishna. All right. I hope, William, now you're clear about the value of K. Hello, Naveen Muthu. Welcome aboard. Hi, Vignesh. Okay. Okay. Come on. Let's see how to solve this question. Momentum is 5t square plus 2t. Find the force and find the acceleration. Very easy. Force was nothing but proportional, but remember it is also equal to dp by dt, you know, in SI units, correct? In SI units is just dp by dt. So just substitute it. D by dt of what is momentum? It is 5t square plus 2t. Now we all know how to find the derivatives. I have taught this to you in my previous classes. In case you have missed it, I highly recommend you to watch those lectures ASAP. That's as soon as possible. Okay, so 5 into derivative of t square plus 2 into derivative of time. Now what is the derivative of t square? That's 2t, right? So it is 5 into 2t. And what's the derivative of t with respect to t? It's 1. Cool. So this will become 10t plus 2. That's the force. But I don't want a general equation. I want it at 2 seconds. So force at 2 seconds will be by substituting time as 2. So hence this is going to be 22 Newton. And that's my first answer. I can see a lot of you got it. Excellent, guys. Excellent. Beautiful. Now the question is, what is acceleration? We know force is mass into acceleration. So acceleration will be that force divided by mass, which is 10. Hence it will be 2.2 meters per second square. That's my second answer. Clear? Very good. Very good. Very good. Excellent, guys. Beautiful. Amazing. Yes, it is also 11 by 5. Let's do the next question coming up on your screen. Very good. This was a confidence booster question coupled with derivatives. Like you can see, that's the answer. Coming up on your screen now. 3 forces are there. F1 and F2 are given. Find F3 if acceleration is given. Interesting. F1, F2 are given. Find acceleration. Find the third force if acceleration is 5 I cap. Now 5 I cap means the acceleration is over here. The acceleration is 5 meters per second square in the x-axis. Okay, this is interesting. What is the acceleration in y-axis? Is it given? No, right? Now think about it. If acceleration is only in x-axis, I cap, then the acceleration in y-axis should be how much, guys? Quickly let me know in the chat box. Quickly let me know in the chat box. Suchi Mama saying 0. The acceleration in the y-axis will be 0, right? It's only accelerating in x. There is no acceleration in y. So it's 0. So if there is no acceleration in y, that means the net force in the y direction should also be 0. Net force in the y direction should be 0. Very obvious. Second thing which is obvious is also, since acceleration in x-axis is 5, hence total force in the x direction will be the mass into the acceleration, which is 5. All the forces in x will produce acceleration in x. All forces in y will produce acceleration in y. But since there is no acceleration in y, so there is no net force in the y direction. Since there is acceleration in x, there is net force in the x direction. Now, the next step is also obvious. We have to split the forces. Split the forces, obviously. What are you going to do? You're going to split the forces, right? Okay, I think this is very common angle. You should know this by now. 37 means 3, 4, 5 triangle. Everybody should know this. 3, 4, 5 triangle is 37, 53, 90 degrees triangle. It's a standard triangle. Okay, so hence, think about it. The force which will be here and here, you can figure this out very easily. This will be 5 cos 37, and if you remember the value of cos 37, very good. And if you did not know this, well, what should I say? It is 4 by 5, and hence this will be 4 Newton. This will be 4 Newton, and this force, this will be 3 Newton by the same logic. It will be sine 37 component. Cool? Great. What about this force? This is 8 root 2, this is 45. So there will be 2 components. Each component will be 8 root 2 sine 45 cos 45. Now sine 45 is 1 by root 2. Root 2 into 1 by root 2 gone. So you will just have 8 Newton here and 8 Newton here. Correct? Now guys, think carefully. Carefully you think about it. Think about this. Observe. Look at only y direction. 8 Newton down, 3 Newton up. 8 Newton down, 3 Newton up. But the total force should be 0, right? So think, what should be the y component of F3? What should be the y component of F3? F3y and F3x. There will be 2 components. What should be the y component of F3? Quickly let me know in the chat box. Think about it carefully. 8 down, 3 up. How much more should be there to make sure total force is 0? 8 minus 3, right? 8 minus 3, right? Which is nothing but 5 Newton. Everybody getting it? Everybody understanding this, guys? Very good. Excellente, guys. Excellente. Now think about it. In the x direction, okay? In the x direction, think the total force should be m into 5. Is the mass given? Yes. What is the mass given? The mass was given to be 2 and acceleration was 5. Okay, so the mass was 2, the acceleration was 5. So think, what are the forces in the x direction? One is 8. Okay, then 4 is there, but it is minus 4, correct? Because it's opposite. And this guy's horizontal component, which is F3x. This should be 2 into 5, which is 10. So guys, what will be the value of F3x? Think about it. 8 minus 4, 4. 4, if you take it that side, minus 4. 10 minus 4, 6. So this should be 6 Newton. Everybody getting it? Roshni, very good. Excellent. So 8 minus 4 plus this guy's component will be mass into acceleration. That's it. So hence, the third force will be, 6 I cap plus 5 J cap Newton. That's the answer. How many of you got this now? How many of you got this? Please let me know by putting up a yo in the chat box. It means a lot. Okay, cool. Shall we go ahead? Let me know, guys. Let me know. Thank you so much, Kshitij. And by the way, our fees are way less. It's hardly 3,000 to 2,700 rupees per month, including KVPY, including Olympiads, including micro courses, revision, test series, national ranking, booklets, everything, doubt solving, everything. Okay, cool. Chalo. Let's get going to the next one. Okay, Newton's third law, let's talk about it. We have to if you have to find the magnitude, Avi Munges, what will you do? Just take the modulus. Just take the modulus. The modulus of this will be root of 6 square plus 5 square. If you had to find the magnitude, that's it. But here, I'm not sure if you can see this. This is actually bold. So that means actually this is nothing but F3 bar. So you have to put something I and something J. So that's why I have left it in IJK form. Okay. So see the options. Accordingly, we'll get it. Okay. Next, Newton's third law. Now this is most famous and a lot of jokes on this. Okay. So here is the thing. Whenever you pull something, even that object or that person will also push or pull you, and these two things always occur simultaneously. If one force, if you call it as the action, the second force which happens instantly, the reason is, you know, the moment one force comes into existence, the second, the Judwa Bhai, the twin brother, automatically comes into existence. That second force, the twin brother of that force, is called as the reaction. And you can see that very clearly in this simulation. This person is shooting bullets. The gun is applying force on the bullets. So the bullet is applying force on the person in the opposite direction. You can see that. The forces are equal opposite, but they do not cancel each other. Why are they not cancelling each other? Simple. Because the force are acting on two different objects. One is the force by the gun on the bullets. The reaction is by the bullet on the gun. On the gun, on the bullet. Two different objects. So that's why they won't cancel. Think about it this way. If I tell you there is the bullet here and there is a force acting like this, and there is a gun here and the force acting is like this, will these two forces cancel each other? Obviously not, because they are on two different objects. But if it was the same object and the forces were on the same object, then yes, they will cancel. So that's the logic behind it. Cool. So for every action, there is an equal and opposite reaction. And yes, Santwana Dange, I'll be teaching FBD very soon. And they do not cancel each other as they act on different bodies. Force by 1 on 2 is the force by 2 on 1, but the sign is opposite. That's it. As simple as that. Okay. So very simple. I have just explained it. If there are two objects, force is here and the force is here, they will not cancel because they are force on two different bodies. But same body, if the same force applies magnitude, they will cancel. So Newton's third law is such that, you know, the force by the bullet on the gun and the force by the gun on the bullet, they are on two different objects, so they will not cancel each other. Okay, I hope Mangad that is clear. Think about it carefully, bacha. Whom is the force acting on? It's very simple statement. It's very simple statement. Who is the force acting on? Once it is on the bullet, once it is on the gun. How are they going to cancel? If I had to cancel, they should be on the same thing, right? Okay, cool. Let's get going to the question based on this. Let's see how many of you can do this. Okay, come on. First question on third law. Tug of war. Okay, beautiful question on tug of war. Team A versus Team B, and Team B is winning. Team B is winning. Who has applied more force on the rope? Okay. Come on, come on, come on, come on, come on. Let's see. Santhana Dange, how would I know what your coaching is going to do, man? At least over here, I'm going to do everything. Just focus on the session right now. Okay, let's see how many of you can do this. Guys, gone. All of you are wrong. Pura gone. Everybody is wrong. Everybody is wrong. Guys, the answer is C. It is same. It is going to be same. How the hell can it be different, guys? Think about it. Team B pulls Team A. Team B pulls Team A by Newton's third law. Team A is also pulling Team B via that rope. These are action, reaction. By Newton's third law, they should be equal and opposite, but on two different bodies. Hence, it should be same. Most of you are wrong. That's why attending these classes are important, and that's why you should start from the basics. Students don't know the basics, and you guys are talking about Erodo. Man, first learn this basics. Learn this basics. Now you'll be like, sir, then how did Team B win? How did Team B win? The reason why Team B won is not because of the force on the rope. It's because of the force on the ground. Their grip was better. Imagine like this. Team A was on a slippery surface. Team B was on a solid ground, rough surface with good shoes. Obviously, they'll have good grip. They will not slip. So as they pull, Team A will start sliding. They will lose. But similarly, they might be all bulky people, they might be all thin people, doesn't matter. If these people were on a smooth surface and these people were on a rough ground, they will have better grip, and that's when Team A will win and Team B will lose. Doesn't matter who is in whose team, doesn't matter. It's only because of friction. Okay, so Newton's third law at play. A lot of people make this mistake. Okay, people think, oh, I applied more force on the rope. It's never about the force on the rope. If both have the same friction, then it depends on who will give up first. Some person will be like, okay, I'm tired, I'm leaving this rope. That's it, they will lose. Okay, Suganya? Alright. Now, before going ahead, let me tell you, in Vedantu, we give utmost priority to doubts. Like you guys are asking us doubts. There are two ways you can ask doubts. One, in our live classes, there is a second teacher apart from the master teacher, who is continuously solving doubts during live classes. There is another set of teachers specially assigned for after the class doubts. In our mobile app, once you download the Vedantu app, okay, so there is a doubt section. You can post as many doubts, unlimited, free of cost, okay, once you are a part of the pro subscription, from morning till night. And we give you all the doubt clearing facilities of 11th and 12th standard. So that's the best part. So you will never have to, Google it. You don't have to ask some random person, or you never have to be tensed about who is going to solve my doubts. So guys, get all your hints and doubts cleared through the Vedantu's Doubt App facility. Going to the different kinds of forces. There is only one app, Zayed, the student version. Now, here is the thing. What are the different forces, different types of forces? Number one, let's go through this quickly. One is weight. What is weight? Weight is the force of gravity. The force of gravity is called as weight, and gravitational force will always act downwards. Okay? And whenever I say weight in physics, I always mean force. I don't mean mass. Mass means kgs, weight means newtons. The units are completely different. But in your day-to-day language, when you say what is your weight, you end up mentioning the answer in kg, but that's wrong. Understand? You should be actually asking what's your mass, not your weight. So strictly speaking, weight in physics means force. And every object on earth gets pulled by gravity, and that force is called as weight. And that value is mass into acceleration due to gravity. It will always act towards the center of the earth or vertically downwards. That's what weight is. Everybody clear? Similarly, now just imagine there is a Pandu. Okay, there is a Pandu. Who is that Pandu? Kannan. Kannan. This is Kannan. What a name. Kannan. Kannan's mass is, how much is your mass, Kannan? Is it 80 kg? I don't know. Okay, I'm just guessing. Assuming you are 80 kg. So what will be the weight of Kannan? The weight of Kannan will be 80 into G. What is G? 10. So it will be 800 Newton. So Kanan's weight is 800 Newton, which can be also written down as 80 kg weight. Both are fine. Newton and kg weight means the same thing. Okay, Sandvana, next time you will be the Pandu. Suchi Mama, your weight is 65 Newton. How is it possible, Suchi Mama? So Suchi, if your weight is 65 Newton, then your mass will be 65 by 10, which is 6.5 kg. You are a small baby. Chota baby you are. Okay. Is this how Suchi Mama looks like? I'm not sure. No, you're I think I'm pretty sure your weight will be a little bit more than that for sure. Please don't be so thin. Okay. Chalo, thoda sa khao piyo. Please eat well. What is kgf or kg weight? It's the same thing, Jitesh. It's the same thing. kgf, kg weight means the same thing. Okay. Don't get confused. All right. Tension. Tension means the force which acts within a string or a rod when you pull it. So when you pull a thread, what happens? Or you pull a thread which is over a pulley, there is tension. That tension is because the molecules of the thread are trying to stretch. The bonds are stretching. So that's why tension comes. So the molecules of the thread or the rope or the string, they are trying to move away because of the pull. That creates that tension in the string. Okay. And if you are in a tug of war, tension will be there. Now, if somebody asks you what is the direction of tension, well, it's there both ways, guys. I mean, just think about it. If there are two people pulling the rope, at this point, if somebody asks you what is the tension, it will be here as well as here. It depends which system are you choosing. If I choose this Pandu plus this small part of the rope as a system, then the tension will be here. The tension will always pull. Understand? So this part, this side of the rope will pull this side. So that's the tension. If somebody draws the FBD, if you take the system as this part, then the tension will be here. So it depends on where you choose the system, how you choose the system, the tension will be both ways. Correct. If you suspend something like a block using a string, yes, there is tension. Correct. Now a loose string will never have tension. If you just hang a string, no weight, no pull, no tension. Okay, as simple as that. Now most of the strings will obviously have some load bearing capacity. So if you exceed that tension, the string will collapse, it will snap, it will get cut. So, often you should not load the string close to the maximum capacity. Now, most of the problems will assume that the string is strong enough, it doesn't break, unless specified that this is the maximum tension, then what will you do? So those kind of questions are also there. All right. Next question, next force, guys. What is the next force? The next force is normal force. Now, what is normal force? Whenever you keep an object or whenever two surfaces are in contact, the common surface, if the common surface is drawn and if you draw perpendicular to it, the perpendicular drawn to the common surface is called as the normal force. So this normal force acts perpendicular to the common surface in contact. So whenever two normal means perpendicular, that's the meaning of normal, perpendicular. So whenever two surfaces touch, they will push against each other. So that force, perpendicular, which is push kind of force, is called as the normal. Like keeping this block on the table, or look at this block on an incline. This is the normal force. This is the surface. This is the perpendicular. This is the normal on the block. This is the normal on the wedge. I hope this is clear. And remember one thing. See guys, whenever you draw normal, that means the objects are in contact. But some questions will be there. The object flies off or loses contact. The moment that word is mentioned, that it loses contact, that means the normal force will become 0. Is that clear? Everybody understood this? Shall we go ahead? Shall we go ahead, guys? Please let me know. Come on, put up. I think you guys are lower energy. Come on, show some josh, guys. Yashika, nobody knows, bacha. Okay. JEE aspirants will have two kinds of tension. Correct, Nivesh? Direction of normal, trusty. Look at this. It depends on which object you take. If you take the block, so I know you guys might be thinking, sir, if I have a surface, I can draw the normal here also, I can draw the normal here also. So which direction do I choose? Simple. See, this is the normal. If you are taking the block, the normal will be this way. If you are taking the wedge, the normal will be this way. So depending on which system do you choose, as simple as that. Like over here, let's say there is a stone. It's kept on a surface. On the stone, it will be like this. On the surface, it will be like this. Both are correct, but they act on different bodies. If this is action, then this is reaction. This is via third law. Understand this. This is via third law. Is that clear? Everybody understood this? Shall we go ahead, guys? Everybody clear till this point? Okay. Great. Next. Okay. Next thing, spring force. Now, you might have seen springs in shock absorbers or in a pen or in some machines or at different places in our industry. So these springs are flexible objects and they have something called as the natural length. In their natural length, understand, they, are relaxed. They are not under tension, they are cool, there is no force in them. But when you compress it or when you extend it, that's when the force comes. Now imagine if you have to compress the spring, obviously you have to apply the force like this, right? You have to push it this way. If you have to expand it, stretch it, you have to pull it by applying the force this way. Now this force is found out to be proportional to the extension or compression. This is found out to be proportional to the compression or the extension. Hence, this force is proportional to X. X is the compression or extension, doesn't matter. Therefore, F is equal to Kx. That's the most important formula. Now, what the hell is K? It's the constant of proportionality. So, I'm going to call this as the spring constant. This is the spring constant. And you can check the units. It will be Newton per meter. Now, what does this K represent? This K will represent how stiff the spring is, how hard or soft the spring is. If the spring is very soft, K will be less. If it is very stiff, it's very difficult to expand it, then it will have a large K. Understand? Now, here is the thing. Guys. Now, remember, lot of books write minus over here. Write minus over here. So, understand that minus is not necessary because we are only interested in the magnitude. Yep. Don't be worried about the minus and plus sign because you'll unnecessarily get confused. Just think about the magnitude, direction, you can get it automatically. So, revising this quickly, the spring force is the force exerted because of stretching or compressing a spring, and it is directly proportional to the extension, and that constant is called as the spring constant, which will depend on the spring itself. Is it made of steel? Is it made of aluminium? Or is it made of something else? And the unit is Newton per meter. Okay? Very good. Excellent, guys. Now, let's get going to the next concepts. Okay? Cool. So, now, the last thing I want to talk about today, actually I had a lot of more slides out here drawing the free body diagram, but doesn't look like I'll be able to complete it today. I'll be taking it up in the next class, but I will give you the rules for drawing the free body diagram. Now, what is free body diagram? See guys, remember I told you about choosing a system. Okay, choosing a system. So when you choose a system, you show the forces acting on it. you show the forces on it. You're freeing that body from the rest of the objects because you're freeing it. That's why I call it as a free body diagram. Some people also refer to it as force body diagram, which is also fine because you're showing the forces. Now this FBD is the crucial step of solving Newton's laws problems. Free body diagram or force body diagram. First step, choose your system, isolate it. Pandu, Pandu plus Champa, Pandu plus trolley, Pandu plus Champa plus trolley, whatever. Who decides the system? It's up to you. Anybody can choose anything as a system, but choose a wise system. Don't make a stupid decision there. Show the forces acting on the object. This is very important. On, not by. This on means external. Please understand this. This on means external forces only. Okay? Choosing a system is your choice. It's up to you. Once you do that, choose a reference frame. This is positive, this is upwards, or you can choose this reference frame, or you can choose this reference frame. Up to you guys. You choose some reference frame. Okay? It's your point of view. You will get a hang of it as you solve problems. And then once you are done that, remember in the forces question, I had split the forces into components. I had resolved it. Remember that? So I had taken a force, I had split it into cos, sine components. Okay? I had split it into cos, sine components. So split the forces, that means take the components. Last step, label the forces. Force, F, normal, weight, spring, whatever forces are there, just label it. And in the end, do not forget to show the acceleration of the body. Okay? Remember, acceleration is the effect. All these forces will produce some acceleration. So it's not a force. So just show the acceleration and that completes your FBD. Is that clear? So these are the rules. Guys, please tell me you're going to revise this and come for the next class because I'm going to make you solve a lot of questions out here. Okay, a lot of questions out here. These are Nivesh for 2023, 11th standard students. Okay, clear. So all these questions I'll be taking it up next time. But let me quickly remind you, Trusty, I'll be taking a special lecture only on friction. Okay, so don't worry, I have not mentioned friction here. But friction, there will be a separate class. Don't worry about it. Now, one thing that I would like you guys to know is that in the description box, after some time, you'll get a PDF. Okay, you'll get this PDF. And you will also see there is a link for joining the 𝐊𝐕𝐿 crash course, which is for 4,000 rupees. The 𝐊𝐕𝐿 examination, which is going to be conducted in November, the course for that has already started. But there is one more opportunity window for you. There is one more batch starting on Monday. So if you want to join that fresh batch, if you don't want to watch the missed classes as recorded, you can join that as well. It's for 4,000 rupees. If you have some money in the wallet, that gets deducted. So that's one link which you should check. Vedantu Pro subscription is the next link. This is the proper long-term batch for everything. JEE Mains, JEE Advanced, KVPY, Olympiads, everything is included in this. You don't have to pay a single penny for any batch once you are in the pro subscription. See guys, it's like Amazon Prime. You get Amazon Music, you get shopping Prime membership, you get movies, so many benefits. Same way, here also, once you are in the pro subscription, you get the long-term batch, you get the doubts, you get booklets, you get assignments, test series, KVPY batches, recordings of all the classes, and the notes, and obviously best teachers like me. Okay, by the way, the course price is hardly 53,999 for 2 years. I'll repeat it. This is the price for 2 years. Now there are 3 packages, Classic and Plus are also there. Now the only difference in them is whether you want the doubt solving on the app or not. If you want the doubt solving on the app, then you go for the Classic version. If you want some special guide, special mentor who will help you analyze your mistakes, who will help you with the scheduling, time management and strategy, then you go for the Plus version. Most students go for the Classic or for the Plus version because they want doubt solving, and some students need special guidance. By the way, you don't have to pay this money upfront. You can just try this course out for 1 month, or you can buy the complete course and you can try it out on EMI option as well. And in EMI auction, you can see it comes out hardly 5,000 rupees, that too for the classic version. The light version is way more cheaper than this. Okay, so you have to use my coupon code SHHPRO, and that's how you can save a lot of money. Like you can see out here, you're saving 7,500 rupees out there. So that's how you enroll yourself in the course. But still, if you have some doubts, do let me know. I'll definitely help you out. Yes, correct. Very good, Shreyas. You got 97.2% in 10th board. Excellent. Mayank, just watch the previous lectures. That's it, and sleep peacefully. Don't sit and study at the last moment, but okay. Santvana, I have not forgotten you, bacha. Okay. Here, yes, don't worry. All right. Bye bye, Kshitij. Take care. See you. Bye bye, Anushvina. Oh, you're saying hello now, but the class is ending. Anyways, Kanan, very good. Kanna, 96.4%. Excellent, excellent. Next class. The next class is going to be on, today is Wednesday, so Friday. Okay, so Friday is going to be your next class. Correct. Okay, Zaid, I'll let you know, bacha. Okay, so next class on Friday. Yes, Santvana, come down to Bangalore. Definitely you can meet me. Okay. Cool. Chalo. 230 clay tsunami is little bit on the lower side. It's not that great. I'm not sure if you will get great branches. Okay. Yeah. Take care, guys. See you. Hasta la vista. This was Shreyas here.